Welcome to what may be the most important word we will use the entire year, the mole. Now, what's interesting about this word mole is that it's a word that means a number. Here's a couple of examples. We know whenever we see the word pair, we know that means 2. We know when we see the word dozen, that equals 12. You might have actually heard of a version called the baker's dozen. And that was when they would try to earn your business by throwing an extra baguette or bun in your basket for your purchase to make it an even 13. You might also have heard of some more obscure ones like score. We hear this in the Gettysburg Address when he says 4 and 7 years ago. That 4 means 4 times 20. Here's another one you might not have heard before. Gross, that's 144, or ream, like a ream of paper, that's 500, and finally a grand, which means 1,000. 1 mole is the same thing, but it's a big number, and here's why. The measuring unit mole is used to quantize very, very, very small items, such as atoms. In other words, when you have atoms that are, or when you have objects that are really small, like atoms or molecules, whose size is on the order of times 10 to the negative 8 centimeters, you need a lot of them to have an amount that's measurable. So 1 mole is 6.02 times 10 to the 23rd. That looks like this. That's a big number, and it's difficult to do on your calculator. So we use scientific notation. So let's bring our calculator up here so we can see what it looks like. Here on your calculator, we have a function here called the EE button. It stands for exponent entry. So on your calculator, when you're trying to enter 6.02 times 10 to the 23rd, it's going to look like this, 6.02. We're going to hit second. See how this little up arrow lights up to show us that we're shifting. EE, and this little E is the calculator's way of saying times 10 to the. And so all we have to do is tell the calculator that we want that exponent to be 23. Now there are going to be some of you that are going to enter it like this. You're going to say 6.02, and you're going to say times 10 to the, you're going to use this little caret function and enter the exponent that way. And that looks great, but I'm telling you that doesn't work. So please don't do it that way. So how do we measure out a mole's worth of atoms? It's actually really simple. So if you look on your periodic table, every element has got these 2 numbers. And we remember that this number here is something called the atomic number, and that is the number of protons. It's also the atom's identity. We're going to ignore that one for now. We're going to focus on this number. If you recall, it's what we call the average atomic mass. And it is the number of protons plus neutrons. And remember that this is an average, and that most examples of carbon are what we call carbon 12. And that means they have got 6 protons and 6 neutrons. What this means for us is that 1 proton has a mass of 1 atomic mass unit. And so that means that on average, one atom of carbon is going to have an atomic mass of 12 atomic mass units because you've got 6 protons and 6 neutrons. So that's what we're going to call 12 AMU. This value is going to be something else for us. We're going to call this the molar mass. We're usually going to round it. So for carbon, the molar mass is 12. Notice that this is in grams. This means that 12 grams of carbon is 1 mole of carbon. And that means that 1 mole of that carbon, if you have 12 grams, is equal to 6.02 times 10 to the 23rd atoms of carbon. We're going to worry about that later. Let's just crank out a couple of moles and see how this works. Every element has its own atomic mass that is equal to its molar mass. So for neon, its atomic mass is 20.18 atomic mass units. That means that its molar mass is the same value, 20.18 grams. What this means, if you weigh out 20.18 grams of neon, you have 1 mole. And that means that if you have 1 mole, you have exactly 6.02 times 10 to the 23rd atoms of neon. And that's all it is. That means that if you weigh out exactly 15.994 grams of oxygen, you have 1 mole. If you weigh out 31.998 grams of oxygen, you have 2 moles. If you weigh out 7.997 grams of oxygen, you have 1/2 of a mole. So to help us out with this, we're going to use what's called a conversion factor, what you might heard of before as a picket fence. You're all making faces, but a conversion factor is actually a useful tool. What it helps us do is switch from the unit we have to the unit we want. So here's how this works. We're going to start off by identifying what we want. And here is the value that we're starting with. We're going to multiply this by our conversion factor. We're going to put the unit we have on the bottom and the unit we want on the top. When we do this, the unit we have cancels. What we're left is the unit we want. And when we multiply what we have by the unit we want, divided by the unit we have, that spits out our answer. I'll show you what I'm talking about. So here's a question you can expect to see. It's asking, how many moles of carbon do we have if we have 300 grams? So the question is asking, how many moles are the equivalent of 300 grams? So we have the unit that we want, moles of carbon. We have the unit that we have, 300, and we're starting, the unit that we have, which is grams, and we're starting at 300. So here's how the picket fence works. We're going to set this up with the unit that we have on the bottom, grams of carbon. Unit that we want goes on the top, moles of carbon. And we know from this guy that there are 12.011 grams. Feel free to round. We'll round that to 12 in 1 mole. So that goes right here. In 1 mole, there are 12 grams. Here's our calculator. And we're going to say, let's move this over here so we can see what I'm doing. We're going to multiply across the top, and we're going to divide by the bottom. So we're going to say 300 times 1, which we don't need to do, divided by 12. We're doing this all in one big shot. This is 25 moles of carbon. Okay. See you on the next one. Let me get rid of this. Bye.